Peter Tompkins, in his book Secrets of the Great Pyramid, expressed it well. It must have required the organizing capacity of a genius to plan all the work, to lay it out, to provide for emergencies and accidents, to see that the men on the quarries, on the boats and sleds, and in the masons' and smithy shops were all continuously and usefully employed, that the water supply was ample, that the sick reliefs were on hand. If one takes into account the problem of quarrying, roughing out, transporting over 2 million core stones, and finishing some 115,000 enormous casing stones to a precision of 1/100th of an inch, and then raising them into their correct place in a unified, polished structure, the mind boggles at the enormity of the effort. Having considered how the Great Pyramid may have been built, still two mysteries remain. Who built it? Why? All of the other pyramids of Egypt were tombs, and although no firm ancient evidence exists, the tomb theory has always satisfied most students of the Great Pyramid. Frank Chaloux, author and lecturer, is one of the many archaeologists who are convinced that the Great Pyramid is not a tomb.
The reason that the Great Pyramid is not a gigantic tomb is evidenced by the fact that when we do examine the coffer in the king's chamber, there are no inscriptions thereon, no embellishments, neither any on the walls, any hieroglyphs in honor of such a king and his deeds. And of course, historically speaking, there never was a body found. No evidence of that kind whatsoever. And we know that the sarcophagus couldn't have been drawn up its passages because the width of the coffer would prohibit its being drawn along the passage system into this inner chamber. And also, the peculiar fact is that there is no lid, nor were there any fragments of such a lid ever found. This lidless coffer seems to suggest that this represents the chamber of the open tomb, that this room is not a tomb of death, but a room of life, further corroborated by the fact that there are ventilating tubes bringing in oxygen from the outer atmosphere into this room. In other words, there's some other signification involved with regard to the reason for the erection of the structure.
The suggestion that the Great Pyramid was not a tomb makes it unique among the other Egyptian pyramids. Unlike the others, which contain elaborate tributes to their builders, the Great Pyramid furnishes no such clue to the identity of its architect. Indeed, the only reference to the name of Cheops is a quarry mark scrawled by a workman on one of the concealed stones above the king's chamber. But if it was not a tomb, what was it? Many theories have been offered. Mystics claim that it was a temple of secret initiation. A few commentators believed it to have been a granary built by the patriarch Joseph, a refuge from another flood, or an astronomical observatory. Bizarre theories have arisen claiming that it sharpens razor blades, heightens consciousness, preserves food, and so forth. Today, books about pyramid power flood the bookstores with conflicting claims and contradictory reports. It would seem that the more one studies this ancient wonder, the more mysterious it becomes. Can scientific investigation shed any light on the purpose of the Great Pyramid? Modern explorers such as Jomard, Coutel, John Greaves, Dickinson, Lepsius, Howard Weiss, Piazzi Smythe, Flinders Petre, and Morton Edgar have surveyed and measured the pyramid. They dug for hidden passages. They measured every passage and chamber. They discovered original air passages to the king's and queen's chambers. Excavating the modern rubble, they unearthed the only remaining casing stones. They computed the height and debated the conflicting measurements of the base length. A startling new scientific theory emerged. In this theory, the pyramid's measurements teach principles of mathematics, geography, and astronomy. Mr. Jerry Leslie, a Portland, Oregon-based computer specialist, describes some of the scientific discoveries of the last 150 years.
It is the scientist's role to discern truth from speculation. Like many areas of research, it is often the simple that turns out to be the most sublime. And yet it is so often overlooked. In the mid-1800s, John Taylor, a British amateur mathematician and astronomer, developed a curiosity about the Great Pyramid. He analyzed the measurements of Colonel Howard Weiss, who had just returned from an expedition to Egypt. Taylor was intrigued by the fact that the pyramid faces were built at the odd angle of 51 degrees and 51 minutes. As he studied the measurements, Taylor made an astounding discovery. The height of the pyramid was mathematically related to the distance around the base in exactly the same proportion as the radius of a circle is related to its circumference. Taylor found that considering the height of this pyramid as a radius, the circumference of that circle would be the same as the perimeter of the base of the pyramid. No other pyramid bears this ratio. The pyramid had been designed to be a geometrical solution to one of mankind's most difficult mathematical challenges, the squaring of a circle. When Taylor published his findings, other astronomers, mathematicians, and explorers began investigations of the Great Pyramid to test his theories. These men uncovered many more facts about the pyramid, facts and proportions that indicate advanced scientific knowledge on the part of the pyramid builders. One of these points, the pi proportion discovered by Taylor, was later proved to be accurate to at least 4 decimal points. Yet it was 2,700 years later before mathematicians computed pi to that accuracy. And not till the 16th century was it computed to 6 and 7 decimal places. The King's Chamber and coffer also demonstrate that pi proportion. This is shown in the ratio of the length to the perimeter. A second point found by some of these men was that the cross-section of the pyramid fulfills the famous golden section ratio. That is 1.618, which supposedly was not discovered until 1,000 years later by the ancient Greeks. This was found to be the exact ratio of half the base to the length of the apothem, that is, the line from the mid-base point up to the apex of the pyramid. Now let's take a look at a third point. Isaac Newton computed the sacred cubit of Moses' tabernacle and Solomon's temple and the Great Pyramid to be about 25 British inches. Sir John F.W. Herschel calculated that 1/10,000,000th part of the Earth's polar axis would be 25.025 British inches. Herschel proposed this unit of measure to the world as being more accurate than the French meter, which had been based on the curved line from the pole to the equator. Along came Taylor and Scotland's royal astronomer Piazzi Smyth and others with a startling discovery. The number of Herschel's cubits in the baseline length of the Great Pyramid is 365.242. That is exactly the number of days in a year. This was dubbed the pyramid cubit, and 1/25th part of it was called the pyramid inch. Many other places in the pyramid reveal this special dimension.